Okay, today I'm going to teach you another method to solve a system of equations. It's called elimination. So that word means you want to eliminate one of the variables and solve for another. So the elimination method. So again, the elimination method is a method for solving systems of equations by adding or subtracting to eliminate a variable. So you're going to stack these like an old-fashioned addition or subtraction problem. Okay, here are the steps to solve. Step 1. Make sure the variables are lined up. So your x's should be stacked one on top of each other, and your y's should, and your constant. So make sure your variables are lined up. So that's step 1. Step 2 is add or subtract the equations to eliminate a variable with common coefficients. So add or subtract both the equations to eliminate the variable with a common coefficient. That's the number before the variable. I'm going to run out of room. I write small. So that's step 2. Step 3, solve for the remaining variable. Step 4, substitute that answer that you got into the original. And solve for the other variable. Sounds like a lot. It's really a combination of elimination and substitution. So let's take a look at these steps in action. Okay, so we're trying to eliminate. So number 1 is stacked up, the y's, the x's, and the constants. So if the variable with common coefficient has the same sign, you're going to subtract. Okay? Now, if you remember, subtracting is adding the opposite. Now, you don't have to do this. If you can just subtract, but this is how I always do this. So we're going to change this subtraction to addition, and we're going to change all the signs. Okay? So the y's are gone because y minus y is 0. Keep that equal sign there. So 3x minus x is 2x, and 4 plus 2 is 6. Okay, now we need to isolate that x, so we're going to subtract 6 from either side. So I have negative 6 equals 2x. I'm going to divide by 2, so I have the value for x. When I find the value for x, I need to put that into one of the equations. I'm going to put it into the top one where I did not change the signs. We're going to get what the value of y is. So now I have y equals 3, and instead of x, we're going to substitute that negative 3 that we found for the value of x plus 4. So y is equal to negative 9 plus 4, so y is negative 5. If you put these together into an ordered pair, and this would be the place that the 2 lines would cross, you would have negative 3, negative 5. And that's your solution. If you were to plug these x and y values into both of those equations, they both would be true. Okay, let's try number 2. So our x's have a common coefficient of 1. They have the same sign, so we're going to subtract. I'm going to change that subtraction to addition. You don't have to do this. You can just subtract if you want to. And now I'm going to add. So again, we have 0 here. 4y and y is 5y. 13 plus negative 3 is 10. Whoops. So I have 5y equals 10. When I divide each side by 5, y has a value of 2. Now we're going to plug it in. I'm going to go on the top one where I didn't change the signs because you want to plug into the original. X plus 4 times 2. If you solved for y first, make sure you plug it in for the y value. So I have x plus 8 equals 13. And when I subtract 8 from both sides, I have x equals 5. So my solution is 5, 2. Remember to write down your solution. Okay, number 3. So again, my x value has the common coefficient of 3. The signs are the same. So I'm going to subtract. I'm going to change that subtraction to addition, and I'm going to change the signs. So my 3's are eliminated. I have 0 and negative 10y, and positive is negative y. And then I have 14 minus 15, that's negative 1. So let's divide by negative 1 to hop that sign over. So y is 1. Now I'm going to take what we found for y, and I'm going to plug it into the original for y. So I have 3x minus 10 times 1 equals 14. When I add 10 to both sides, I have 3x equals 24. I'm going to divide each side by 3. X equals 8. So my ordered pair is 8, 1. That's my solution. Okay, over here on number 4, I'm looking for my common coefficient, and it comes in the middle, and that's okay. So the signs are the same. They're both positive. So I'm going to subtract. Again, I'm going to change that to addition and change all of the signs. So 4x plus 2x is 6x. The two y's are canceled because one's negative and one's positive. And 6 plus negative 18 gives me negative 12. I'm going to divide by 6 on each side, so x is negative 2. Now I'm going to plug that value in for x. So 4 times negative 2 plus 2y equals 6. So I have negative 8 plus 2y equals 6. And when I add that 8 to each side, I have 2y equals 14. Divide by 2. So my y value is 7. My ordered pair is negative 2, 7. All right, problem number 5. We're going to skip around. I'll do the next couple in order, and then we're going to skip. So look at I have 4's in front of the x's, so those are my common coefficients, except one's negative. So when you have two different signs here, you can just add, because adding them makes them disappear. Okay? So now I have 9y and 17y, so that's 16y equals 16. And when I divide each side by 16, I get 1. Now we're going to go back up here and plug that in where y is. So, oops, this is a plus, sorry. 9 times 1 equals 5. So I have 4x plus 9 equals 5. When I subtract 9 from both sides, I have 4x equals negative 4. I'm going to divide by 4, and x is negative 1. So now my ordered pair, that's the solution, is negative 1, 1. Number 6. So what's common here is my 3's. So the signs are opposite. So I'm just going to add, which gets rid of my 3y's. So I have 10x and minus 2x is 8x equals 24. And when I divide by 8, I have x is 3. I'm going to plug that back in. So I have 10 times 3 minus 3y equals 18. I'm going to multiply 10 times 3, that's 30, minus 3y equals 18. I'm going to subtract that 30 from each side. So I have negative 3y equals negative 12. I'm going to divide by negative 3, so y is 4. So here, my ordered pair is 3, 4. All right, here's where we're going to skip down to 10. 10 and 11 are important because they're the oddballs. So, you know, we have two choices here for number 10. I'm going to choose to get rid of the 3's. So they have the same sign, so I'm going to subtract, and I'm going to change that addition and add or make all the signs opposite. So I'm canceling the 3's, and the 4's are canceled. So I have nothing on this side. My variables are gone, and uh-oh. All right, let me go back. And I end up with 0 equals 3. And just like we did before in substitution, if your variables are gone and the numbers equal each other, this is a no solution. These problems go really quick. Okay, so look at number 11. Well, there's something wrong first. The variables aren't lined up. So the first thing we need to do is rearrange the second one so we line everything up. So to do that, I'm going to have to 2x both sides. So now I have negative 2x minus y. Okay, so again, these babies are gone when we add everything. I have 0, and then negative 10 plus 10 is 0. This time we have the same thing on the side of the equal sign, so my answer is all real numbers, or you can the infinity symbol. That means no matter what you plugged in there, it would work. All right, so what happens if there are no common coefficients and you cannot cancel? So I'm going to get these rules down and we're going to have to go to part 2. So what happens? You need to multiply one or both of the equations by some number to create matching or opposite coefficients. So again, you're going to have to multiply one or both of the equations so that you can force a way to eliminate one of the variables. All right, so I'm going to stop here and we'll do examples in the second part.